This is a little interactive demo I put together. You can grab this character, spin him around, and when you let go, he smoothly snaps back onto his trajectory. I've linked it in the description below so you can try it out for yourself in your browser right now. This marks the very first milestone on my journey of building a custom game engine from scratch using C++ and WebGPU. A huge chunk of early development is just dry project setup, so I wanted to give you a little bit of interactive eye candy up front while I lay down the core infrastructure. In this demo, I'm skipping the boring boilerplate and showing you the key stages of how I brought this little guy to life, starting with the artwork. For this project, I knew I wanted our main character to be an engineer. I'm a huge fan of factory games, so technical gears and machinery felt like a fun starting point to play around with. I've actually tried designing an engineer character in the past, but the results were pretty mediocre. Lately I've been obsessed with this specific illustration style by artists like Armin Faramazian and Aivo. I realized this was the perfect direction to fix the lack of appeal in my older design, and shoutouts to them. Their stuff is really great and helped me get a grasp on this aesthetic. The style relies on simple bubbly shapes, clean shading, soft outlines, tinted to match each color. I have experimented with this style before on a few casual sketches, but I've never gotten around to actually building a full project around one, until now. When sketching this pose, I intentionally went with super loose comic style limbs. The trick with a stylized look like this is resisting the urge to get bogged down in realistic anatomy or knee structure. It's all about flow. The same rule also applies for clothes and accessories. I wanted everything to feel like molded clay. Smooth, round shapes, zero creases, almost like every element is its own little squidgy blob. I also threw in some floating accents, which is a detail I absolutely adore in this style. I do wish the character interacted with the floating bits a little more here, but that's something I'll definitely push further in future designs. To wrap it up, I used a solid colored rectangle behind him to frame the silhouette, using a sharp orange accent to pop against the blue background. Overall, I'm pretty happy with how this turned out, and it gives us a fantastic blueprint for the 3D model. Jumping over to Blender, I started blocking out the character. The subdivision modifier is an absolute dream for this bubbly style, letting you sculpt soft shapes right out of basic primitives. Initially, I wanted to use traditional outlines, but with overlapping clothes and skins, it quickly turned into a clipping nightmare. Luckily, this art style relies so heavily on soft, bulky volumes that a cell shader can do all the heavy lifting instead. So let's take a quick detour into how this cell shader actually works under the hood. At its core, every surface has a normal, a vector pointing straight out perpendicular to the mesh. To shade the object, we calculate the dot product between that normal and our light direction. That gives us a value from 0 to 1, mapping to black and white, depending how directly the light hits the surface. To get that classic toon look, instead of a smooth gradient, we pass that value through a step function, forcing it into distinct bands of light and dark. From here, it's just a matter of swapping out black and white for our actual light and shadow colors, and adding a threshold to tweak the size of the bands to taste. Back in Blender, I ran into a bit of a wall with the facial features. My first instinct was to draw them using grease pencil, but it just didn't sit right in the 3D space, and if I tried to pull it closer, the strokes started clipping, so I pivoted to this strategy instead. By using the skin modifier combined with the subdivision surface, you can convert basic stick lines into volumetric 3D curves. From there, you can easily scale individual vertices to taper the width, giving the eyes and mouth that perfect stylized pop. And it's easy to see how this lends itself nicely for doing other things in this style. And just like that, we've got a solid 3D model that stays remarkably faithful to the original sketch. I applied all the modifiers and joined everything into a single mesh. This meant I didn't have to write engine code to handle complex GLTF node hierarchies or scene graphs, keeping our early pipeline super clean. The resulting model format is as straightforward as it gets. Each vertex simply stores its position, surface normal, and the light versus dark colors of our cell shader. We push that raw array straight onto the GPU and boom, we've got our 3D model. With the model rendering, we're on to the final stretch. A spinning 3D model is cool, but a static render is boring. We want full user interactivity. So I built an orbit camera control so you can click and drag around the character, rotating it in different directions. But I wanted to return to its spinning animation once you let go. How do you smoothly interpolate between two 3D rotations? For that, let's take a look at quaternions. Now, I won't pretend to give a full lecture on quaternions here. Penguin maths and 3 blue 1 brown have incredible incredible videos on this topic that I've linked down in the description. But for our rotation math, the core idea revolves around applying a quaternion like this. For those curious, you do this by storing our vector v with real part 0, then constructing a unit quaternion using a unit vector u and an angle theta. Keep in mind that theta is actually twice your intended rotation angle, since you're applying q front and back, which means you're effectively applying the rotation twice. Once we have our orientation stored in this way, we can start doing some really cool tricks with it. Having the character spin on his own and letting the player control the camera covers the two base rotation states, q1 and q2. The real magic happens when you try to transition between them. To get from q1 to q2, we solve for the difference, or delta quaternion, but applying that directly just instantly snaps the character into place. To make it smooth, we need to interpolate. By scaling the rotation angle of that delta quaternion over a time variable t from 0 to 1, we can get a clean spherical linear interpolation, or SLERP, allowing our object to flow linearly between the two rotations. To give it that final bit of juice, I didn't want a flat linear speed. I added a slight stall when you release, then ease the rotation using a simple polynomial, x squared, so he accelerates back into his trajectory with some real weight. And that's it. We've come a long way from sketching our initial 2D concept to modeling him in Blender, leveraging the cell shader to skip the complex outlines, streamlining our mesh for WebGPU, and making him spin interactively with quaternions. Thank you so much for watching. Give the live demo down in the description a try, and see ya!